Hello student, let me explain again how to reach our course web page in the Google. Type my name, click the first one, and then click teaching, and then click financial case research. And this is our syllabus. In syllabus, click class material. Sorry, again, click this one. And then click the very first one. Learning R with machine learning. So in the previous class, we learned what is neural network. Okay, so yeah, this was a neural network, right? So very simple neural network. So this is input layer, this one, in which we put our input. They are called input layer. So let me write down. So let me choose red one. So these three, they are input layers, and this in the middle, they are hidden. They connect the input to the output, so there is hidden layers. And this is called output layer. Right? And then let's select this entire content like this, and then copy, and then our course web page, right? And then let's add a slide, and let's add the one, copy and paste over here. Yes, here. So now you can take a look at this figure as well. Okay? And then we downloaded, in the previous class, we downloaded the lecture note. We downloaded the nnet. This is the manual about the package called nnet, which is useful for neural network analysis reading R. And then we also downloaded this lecture note. Let me go there again. And week 7, then download this one. Actually, we already downloaded it, but yes. We need the content from 6. And there are some concepts like output layer, output layer, and the input layer, and hidden layer. We learned that. And nodes. Nodes are basically connections. Okay? And then if you are interested more about the neural network, you can always use Google neural network, artificial neural network actually. So you can click this one. Right, so this input layer, hidden layer, and output layer. In this case, we have 2 output layers. So there are more explanations in Wikipedia. So if you are interested in what is neural network more, you can read this article. Right, it shows you history, and then some background. Okay. Close it. And then in our course web page, in the slide, well, this is lecture notes. We just downloaded our lecture notes, and then this is manual about nnet package, and actually there's sample code over here. You can click that, and you can reach the sample code over here. So let me explain this sample code, and then let me explain machine learning as well. So first one, let's first one is called set working directory. So here I will download the files in the on the C drive and temp folder, and I will work in the directory. So in the computer, let's go to the C drive. Let's go to C drive. C drive. So this is C drive, and in the C drive there is already a folder called temp. So I don't have to make temp. So if let me delete it. Okay. In this case, there is no temp. So if there is no folder name temp, you can simply make one. Click this one and temp. Okay, here, and then let's go to R. So this is R. Now here, let's copy and paste the first one. Set working directory. Set temp. So now, because I set working directory is a C temp, so now I can use the file in this folder. Okay, so this one is basically, let me write it actually. Just a moment. This is previous one. Okay. So let me copy and paste the first one, then again, then I set working directory. And the second one is now x equals can, and the file name, double quote, mibmln2699.txt. So basically what this line does is that we scan this file, right? And then the information in this file is stored with variable name x. So in order to execute this line, we need this file, right? And then we can get this file in our course web page again. In the course web page, previous week 7, and then let's find the file. The file is, I guess, this one, right? The file name, not this one. So, right, mibmln2699. So here, we said 2699. So let's download this file. This file is downloaded, and open folder. Okay, and then let's move this file to the working directory, which is c/temp. So I copy and then go to C drive, temp, and paste. Right? So now we have this file. So you open this file, well, it has a bunch of actually returns, information about stock return of the IBM actually. So again, we can go to our course web page, and now let's copy this second line, copy, and then paste, right? Paste, then x equals can mibm ln2699.txt. So it read 888 items. If you type x, then it shows everything. Well, this is too much. So instead, what we can do is we can type head and x, then it will show the only first 6 items in the file. On the other hand, if type tail and x, then it will show you the last 6 items in the file. So last 6 one, the very last one, last 6 items in the file. So that's it seems that everything is all right. And third one, this histogram. This generate histogram. So right, histogram, right? So histogram is the around 0 it has a lot, so it is typical distribution of the stock return. It looks like normal distribution, but it is actually not normal distribution. Stock return looks similar to normal distribution, but most of stock returns are not normal distribution. Compared with the normal distribution, we have more weight at the corner, and it seems that it has more weight on the corner, and especially a lot of weight in the negative side. So it seems typical stock return distribution. And then in order to close this one, you can close this one, red one, or you can type def off, device off, like this, null device. Okay, and then let's go. By the way, when we type this one, we have this is sharp, and we have sentence. When you put sharp, the computer, the R program cannot read this one. So this is very useful to write your note or to memo some important information. So in this case, head X, you can simply type head X, but I put this one because I want to explain that head X means that this is for checking the first 6 rows. Tail X means that, well, tail means that this is for checking last 6 rows. For computer, they cannot read this one. It is only for yourself. So again, when you code and then you want to explain some line, you can simply put sharp and then write your comment. So it is comment. And next, it seems that we uploaded the file correctly. And next, what we can do is we can run package nnet. We already installed the nnet. So now we want to upload, or we already downloaded nnet and we packaged nnet, so we want to call nnet. We want to call the package. In order to call the package nnet, you can type library and write down the package name. Here we want to use package nnet, so use this one. So go to library, and type package name you want to call. Here nnet. Right? So it's successfully called nnet. In some case, if it doesn't work, you have to go to package tool again and you have to install this nnet package again here. And then let's go back to our data again, and this is X is our data. Basically, we store past stock returns into the variable X, and then Y here, Y is the basically return at time t. So let me copy and paste this one. Okay, so Y, let's study this one. Y is from 4th row to 864. We define this range as Y. Okay, so in the data, we can check dimension of the X. Yes, dimension of X, or length. In this case, we can check length of X. Length is 888. And then, so the first one, like head X, the first items, early items, it means early data. And the late items is recent data. So the data is ordered in terms of time. So the last one, this is the least one, this is old one, okay? And then in this model, what we want to do is we want to predict today's stock return with past 3 days stock return. So we call today's stock return as RT. RT minus 1 is yesterday's stock return, and then RT minus 2 is the day before yesterday, and RT minus 3 is the stock return like 3 days ago. Okay, so we use these 3 days. So in order to estimate what's going to happen to our stock price, we use today's stock price, yesterday's stock price, before yesterday's stock price. So in order to do that, let's define X. So IBM X is combination of those three. Okay. Yes. So let's look at this one. So in Y, in our previous Y is from 4 to 864. We use data until up to 864. We don't use data up to 888. As you remember, the length of data is 888. We use remaining data for test. We use data up to 864 for estimation. Anyway, why is this one? So we use stock return from 4 days to 864 days with t minus 1, t minus 2, t minus 3. So for this one, each one, we match 3 to 863. So it is 3 to x63. So it is basically for each element in this line, for each element y, it matches 1 day, 1 period before returns. Okay. Now the second item is from 2 to A62, right? From 2 to A62, it is 4 to A64. So it means this one is like t minus 2. For each item here, we match t minus 2 item. Last, this one. So this one is 1 to A61. So comparing this one, we have a 3 leg. So it is 3 days ago. So in order to test this matching, what we can do is cbind. Cbind, we basically bind 3 rows. So y and ibm.x, right? Y is this one, ibm.x is this one. So we match it, right? So for each y, this is t minus 1, right? We match this one, and then this one and this one, right? We have these legs. So to estimate this one, basically, we use this information, right? And we use this information, and we use this information. But as you can see, this is the return of the yesterday. You know, the old one is, this is old one, this is new one. So in order to use this one, what we want to do is we use this 3 information, right? This 3 information in order to estimate this one. And this 3 information is, this one is matched here, this one comes here, this one is here, and this one is here, right? So it means that our matching is very well. So for each this one, basically we want to use these 3, which means that to estimate this one, we use this 3 one. Why we do that? Because it is much easier to stack the data in this manner. Okay. So let's check the data tail again. If we use this one again, and we put tail, and then it will show you the last six rows tail, like this one. So again, this is same. To estimate this one, we use this, and this one is over here, this one is over here, this one is this one. So in order to estimate y, we use x1, x2, x3, right? So if we go back to our previous this one, if we use analogy of this one, then actually we delete this one, and then actually we have to delete this one, this one. Oh, sorry, this is this one. We don't need this one, right? So hidden layer, what we wanna do is that this is stock return, actually not stock price. Okay, stock return. Okay, delete this one. Delete this one. Okay, it looks clean now. and instead of stock price, we want to estimate stock return, right? We want stock return. Okay, so what you want to do is stock return. This is RT, right? Output is RT, and then in order to estimate the return at time t, we use RT minus 1, RT minus 2, RT minus 3. So basically RT minus 1 is x1, RT minus 2 is x2, RT minus 3 is x3 in ours. And we want to put this one into the hidden layer, some number of hidden layers, and then using this past 3 data, we want to estimate today's stock return. Okay? And then next step is actually we run neural network, and then this is a command to estimate the neural network. For this part, I will explain in the next class. In the next class, I'll explain this line. Thank you.